here. So good morning, welcome back. What would you like to do first is my question to you. So where we ended up yesterday was finishing the first example using R, going through the steps of building a growth curve model and ending with a time-invariant predictor. And I went through the LME and Elmer syntax to do that. I waved my hand at the corresponding lavaan syntax, and then I promised that we could go over Mplus today. So where would you like to start with all of that? Would you like to learn how to use Mplus? Would that be good? I know a few people know how already, but it's very easy to use. There's just a few idiosyncrasies that you have to get used to. So I have a file open which is example 1's model 3, the MLM version. That's what I'm looking at here. If I don't know if it will recognize the .inp extension if you double click it to open it within that, but you may need to find Mplus on your computers and open it that way if it doesn't work. And if you don't want to play along within Mplus, everything that I have is within example 1b. So I copied the syntax and the output into a Word document that you have a PDF copy of. That way we could use it regardless of what's installed on the machines. So this is the file that I'd like to go over once everybody has it open in front of them inside Mplus. It should look like this. That's not going to be useful if I don't. Mplus is a package that does pretty much everything. The only catch is that it doesn't do anything using residual maximum likelihood estimation. So everything is going to be maximum likelihood or Bayesian estimation, where they do, for the latter, they do a lot of the heavy lifting in terms of what your priors are. There's a bunch of defaults. So those of you who are used to doing Bayesian analyses probably would want to look into exactly what those are and make sure that you're happy with them. But the way that they've sort of pitched it is all you would have to do to change to Bayes is literally just go from estimator equals ML to Bayes, and then everything just sort of works that way. I'm sticking within ML for most things except whenever I have to switch over. That way the output and the results are going to be the same across all of the packages, R, Mplus, and whatnot. So Mplus has, the people who make it have invested all of their effort into the statistics and the modeling and very, very little effort into the interface. So what I have here is just a plain text file. Comments are indicated by exclamation points. And this is one model per file. So unlike every other package that I know where you can have a model and just highlight that model and run it, this runs the entire program as one thing. So that's why there are so many separate files in your download folder, is because it's one model per file. In order to overwrite that, you would have to comment out everything so that it doesn't get read. There is a package I have not yet used, but I've heard good things about in R. It's called Mplus Automation. Are you familiar with this? That does some of the work for you in terms of managing all the different files, and it also brings all of the Mplus output back into R as objects so that you can then work with it. So that may make it a little bit less painful. The type of data that you can use within Mplus also has to be text data. It can be .dat for a tab delimited or fixed format file, or it can be a comma separated values file, CSV. I prefer the latter because you can open it in Excel and see what it looks like. This is the data set that we're going to be using within Mplus. So there's something very different about this data set relative to most. There's no labels. So you cannot have the first row be variable names. It will yell at you. And in fact, that is a very common mistake. Instead, what you have to do is tell it within the script what each of these columns is to be called in the order in which they appear. So it is often easier to cut your data set down just to the variables that you're going to use so that this process is less painful. So the command's title is just what it sounds like. These are words that will appear on your output. Data tells it where the data file is and what format it is. So if your data set is stored in the same physical folder as this syntax INP file, you don't have to put the path to the data set. Otherwise, you do. The default is that it's individual level data and that it's free format, so it's comma separated. You can also provide matrix input if you need to for these things. Then the variables section defines the variables for analysis. So the first one, and arguably the most important to get right, is what the names are. You can only use 8 characters or fewer in your variable names, just like it's 1985 again. So given that the data that you're reading in is just a separate text file, those variables don't know what they used to be called. So you can name them whatever you want because it's only internal within the program at this point. There's no relation to what the data set used to be. So you just have to make sure that you're using 8 characters or fewer. So the variables that we're using here, this is from the example from yesterday. First column is the person ID. This is attitudes, the original variable, measured at the age 12 occasion. Here is an index for which occasion is which. Age is the continuous age variable, so this is a stacked data set that I'm looking at right here. Risky was our outcome variable. Monitoring was the time-varying predictor that we'll get to play with today. Rounded age is the rounded version of age into bins of years so that we could make pictures and things like that. Time then is the variable that is tracking change in age up to age 18 is time 0. So there was a question about that yesterday. Because of I didn't want to get the names confused, and so that's why I switched to time. So that is age minus 18 right there. Likewise, this is the attitudes variable minus 4, so centered such that 4 is the reference for this variable. Here is time squared because you can't define interaction terms on the fly within Mplus. They have to be saved as actual variables. And then this is monitoring centered at 3, which is what we'll end up using as the predictor. So we list all of the names in the order in which they appear, and then the terminating thing is a semicolon in this language. So semicolons finish every separate command. Use variable is listing which of these you're actually going to have in your model. If you forget this line, it will try to throw all of these things into the model, including person ID. So that will go badly. So you want to make sure that you've eliminated columns that you're not currently using. So in this analysis, I have time and time squared. We're going to have attitudes because this is the last model from yesterday, and the risky behavior outcome. Missing data. I always use missing data as a number rather than a dot in Mplus. No worries. In theory, you can just have it be a dot, but I've had it have problems reading dots and confusing them with decimals before. So this might be superstitious behavior, but I always fill in my missing values with some number. So everything would be minus 999, for example, in this data set. Then the next 3 are specific to when you're running a multi-level model or a multi-level SEM in Mplus. You have to tell it how your rows are organized into level 2 units. So cluster is the ID variable that separates, that joins the rows of the same sampling unit together. So it's person ID. And then you also tell it which predictors are to be treated as level-specific observed variables. And in this case, attitude centered at 4 is our between level variable because that is time constant, time invariant, whereas time and time squared are purely on the within level 1. So as we move from models where we're shifting from observed variables to latent variables, this part will change accordingly. But for now, these things are all treated as level-specific observed variables. So any questions on the setup so far? For this type of analysis for the multi-level, it's long. So 1 row per occasion per person. More generally, it's 1 row per level 1 unit, whatever that is. Okay. So then analysis, there's a bunch of choices as to what kind of analysis you have, what type of estimation, and any options within that estimation. What we have is a 2-level model that's going to have random slopes, and so those are the keywords I have to tell it. For estimator, there are several different choices. As I said, the one that I'm using for our purposes is ML. Another one that I would recommend is MLR, which is robust maximum likelihood. That gives you corrected fit statistics and standard errors that are robust to multivariate non-normality, multivariate kurtosis in particular. Just so that the results match across the programs, I'm sticking with regular flavor ML for right now. Then model is where you tell it what you want your model to look like. And the level 1 part of the model is given under this, what is that? Percent sign within percent sign. And the level 2 model is given under this percent sign between option. And the way that you can think about this is literally following the level 1 and level 2 equations. So when you refer to a variable by itself, you are referring to either its variance, if it is a predictor, or its residual leftover variance, if it is an outcome. And according to the terminology that I'm trying to stick with, this is going to be our level 1 E residual variance for the outcome. That's what I'm referring to. I don't actually have to write this, but my preference when I'm teaching code and even when I'm working myself is to err on the side of more typing because there's more transparency in what's being estimated and what's not. Mplus has all kinds of defaults as to what gets estimated and what gets fixed, and I don't want to learn them. I want to know, looking at my code, exactly what's going to happen. So I write more than I have to for the sake of clarity. So I'm referring to the level 1 error variance as one of my estimated parameters. Then here, this syntax here that has this straight bar, this is defining the placeholders for the individual slopes. So the regression of time predicting risky behavior. So y on x is the way to think about it. Whenever I get confused, I just try to remember that on looks like an equal sign. So if when you write the equation, it's y equals, slope times x, blah, 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 it goes in the same order. So on and equals are synonymous in my mind. The name for this regression I have called lin, meaning that's my linear slope. So nothing is being estimated directly. I am setting up the idea that I am going to have this latent variable that operates at level 2. This is just a placeholder for that, in the same way that when we look at the equation for this model, let me pull that up. Basically what I'm doing is creating beta 1 as an idea. The random slope syntax is setting up this placeholder notation. I do the same thing for the other latent variable, which I've called quad. So this is risky on time squared, and it looks like I forgot a semicolon. Very bad. You have to have semicolons at the end of everything, except the comments. Then in the between model, we are referencing the fixed effects, the random effects variances, the random effects covariances, and the regression of our time-invariant predictor predicting the intercept, the linear slope, and the quadratic slope. So rather than intercept as a terminology, it's just the variable again. So risky being in both of these is not actually redundant. Risky in the within model refers to its level 1 E variance. risky in the between model refers to its level 2 random intercept variance. So multiple variables can be partitioned into residual versus random because each is referred to by its name. So anything in, when you write the variables by itself, they're referring to its variances or its leftover variances. Yesterday we discovered that we need a random intercept, we need a random linear age slope, but we did not need a random quadratic age slope variance. It was fixed only. Adding the random age slope variance for the quadratic term did not help the model. So I'm shutting it off by holding it at 0. That creates a fixed slope only, which is referred to in these brackets right here. So anything in a bracket is either the intercept of a variable that is being predicted or the mean of a variable that is not being predicted. It knows which is which based on the context of the rest of the model. So that's not something you have to tell it. So I have my intercept variance right here, my linear age slope variance right here, and no quadratic age slope variance at 0. You do not get covariances among your random effects by default, so I need to add those. So I have risky with means a covariance. It's either a residual covariance or a regular covariance, depending on the context of what it is between. And then finally, on is defining a regression. So X in this case is the attitudes time-invariant predictor centered at 4, and it is predicting all 3 of my terms here, the intercept for risky, the linear age slope that's defined in the within model, and the quadratic age slope that's defined right here as well. Okay, how are we doing? Any of that you want to hear again or ask questions about? And most of what I'm saying is in the comments, by the way, so that you can listen rather than type, but you should be able to add your own notes to the file as well. Yes?
Just because the first line with the bracket, is this one of these extra writing lines?
Which one?
I've never seen it.
The brackets?
Yeah, and I do these analysis all the time in Mplus, so I wonder if this is...
Yes, quite possibly.
Okay, just to make sure.
If I remember correctly, when you define a placeholder level 2 variable, it automatically gets a fixed effect and it automatically gets a random effect variance. So yes, basically I want a line of code to refer to every estimated model parameter so that I know what's there and what's not there. That's my objective, is clarity rather than efficiency.
No, it makes total sense just to make sure that I did not miss an important line.
Nope. And you can always look at your output and go down the list of what you get and see if there's something missing or something extra, right? And then you can refine your code as needed. All right. Other questions? So to make it go, we hit the run button. And if you've done any typing, it will insist that you save it first. Now let's see if this will actually work. Okay, it worked. It made the output very tiny. Let's see if I can make it any bigger. Change font. Yes, please. That's a little better. So Mplus output files are voluminous. If you were to print this, you would kill many forests. And unfortunately, there is no way to shut off pieces of output that you don't want. It just dumps everything, and it dumps it into this unformatted text file. So they put very little effort into the data side and the input and output side. They focus all of their efforts on the modeling. And so this is why the packages like the Mplus automation are very useful to carve this up into the pieces that it actually is. So the first thing that happens in your output file, which is what we're looking at, is that it spits your code back at you. So this is very helpful if you want to share output because your input is part of the same file and you only have to send one file. Then you want to see the magic words. Input reading terminated normally. That means it did not encounter any problems. It spits back information about your data set and your model. So I have 1,400 observations because this is complete data. So I have 200 participants, 7 occasions each. I have 1 dependent variable, that's my risky behavior. I have 3 independent variables, that is time, time squared, and attitudes is my time-invariant predictor. And I have, it thinks, 2 continuous latent variables, although there's actually 3. There is intercept, linear, and quadratic, but I think it's not counting quadratic because it doesn't have a variance. Oh, nope, it is counting quadratic, it's not counting intercept. Whatever. Then it gives you all of the options that are default in terms of the estimation and the convergence criteria and such. Summarizes missing data patterns if you have them. We don't have any missing data. Gives you descriptive statistics for all of your variables. This is useful to make sure that it understood how to read your data correctly. This is the first place I would go if your model looks crazy. Make sure that it understood which column is which. And then another magic phrase, estimation terminated normally. That's always good to know. So then we get into the results. Number of free parameters is actually number of estimated parameters. So think free to not be 0. Is the way I would interpret that. HO is the log likelihood of your model. And you'll note what's not here that's usually part of the output at this point. SEM people, what's not here? Folks who've taken structural equation models or worked with those before? Yeah, there's no other fit. There's no fit statistics. There's no H1 model. There's none of that because this data set can't be summarized by a single covariance matrix. This is long data. So this is the only information you get about fit. You can do relative fit comparisons using the log likelihood value and the AICs and BICs, but there's no absolute fit that's provided within this framework. So then we get to within level and between level results. And the only parameter at level 1 in terms of how it views the model is this right here. This is our level 1 E residual variance. So that corresponds to the variance component in R right here. There's that one. I'm going to switch to, I think, my handout because I have it labeled in here as to what these things are. So we'll scroll down that way. So this is inside a PDF document that you guys have as well, but I went ahead and labeled it so that it would make it easier to walk through. So this is level 1 residual variance so far. Then in the between level, it puts the results in a different order than you write them. It always gives certain things first. So it goes factor loadings, regressions, then covariances, then means and intercepts, and then variances. It's its own decided order. So these are the 3 fixed effects of time-invariant attitudes predicting each of the growth components. So risky, then, that is the effect of attitudes on the intercept. So these were the results that we saw yesterday. For every unit more conservative a mother's attitude is as measured at the age 12 occasion, her daughter's risky behavior at age 18 is lower by 3.5. So that's gamma O1 in the model. That corresponds to this line right here in the R output. Then we have the effect of attitudes on the linear slope. So it looks like, let me make it's positive linear slope. So they are going up less. That's what a negative interaction means in this context. The linear slope itself is positive for the reference group, and this negative interaction makes it less positive. So girls whose mothers have more conservative attitudes had less of an increase in risky behavior at age 18. That's the way I would phrase that. And then the effect of attitudes on the quadratic, not significant, but what it does is make it so that there's less of an acceleration for girls whose mothers are more conservative. Okay, how are we doing so far? All right, so in terms of the table here, I forgot to mention it. The first column is estimate. Second column is standard error. This thing right here, the ratio, that is being treated as a z. It's not a t because there's no denominator degrees of freedom at work here. So that's one of the downsides of using this, is that for small samples, those differences are going to matter. So the combination of a lack of Rummel estimation and a lack of denominator degrees of freedom makes this suboptimal for very small samples of level 2 units. So this is the two-tailed p-value that goes with that z. All right, questions so far? So here's where I'm going to earn my keep as your instructor. Check out this lovely label. Intercepts as a header. It thinks I have 3 intercepts. Last I checked, I only had 1 intercept. But no, what it means are fixed effects. That's what it means. So this is the intercept. It is the conditional mean of the random intercept latent variable, is the way that you can think about that. So this is my fixed intercept. That is the expected risky behavior at age 18 for a girl whose mother's attitudes were a 4. Gamma is 0, 0. Then this is the fixed linear slope, also at age 18, also conditional on attitudes of 4. And this is the fixed quadratic. So the mean or intercept of a latent variable is the same thing as a fixed effect. Likewise, this header, residual variances, what it means by residual is left over. So these are random intercept, random linear variance left over. And this one, the bottom one, oh, no, come back. You'll see that it has an estimate of 0 and a standard error of 0. That's because we fixed it to 0. So if you fix a parameter and say don't estimate it, then you get this. 999 means because it can't divide by 0. So whenever you see that, it means that the parameter wasn't estimated, not that it was a z-score of 999. I've had students get confused on this point, so that's why I'm making it. All right. So what do you think about this? Doable? Maybe, with some practice? What would we have to change, do you think, if we wanted to have a random quadratic variance? Let's play with this a little bit. In the code, what would be different if I wanted to actually estimate that random age slope variance instead of have it be fixed? I'd have to delete the at 0, that's right. Anything else? And then I have to space this back over because I'm that kind of person. Everything has to be aligned. Do I need to add anything? If I estimate the random age, quadratic age slope variance, do I need anything else with it? I need the covariances. So it will not put them in unless you ask. So here is a efficient way to ask for all possible covariances among a series of variables, is you write them all on both sides of the width, like this. That means all of them. Now, one thing you want to be careful of, this comment over here is now at column 84, which I can tell with the tiny little letters in the bottom right corner. Mplus will not read anything past column 90. It just stops reading. It'll say, it'll give you an error and warn you, I'm not going to read this, and it just won't. So often at the beginning of my my programs, you'll see sometimes I'll have like a row of exclamation points out to 90 as sort of like my own, like, don't go past this fence kind of thing. But this is only at 84, so we should be okay. So if we get this right, I'll hit run, and it'll say, you need to save it first, and I'll say, okay. Then it runs, and then the new term that we have should show up. Yep. Now I have my quadratic leftover variance right here, and the new covariances that we asked for right here. And this p-value, by the way, you will see people try to use that to decide whether or not that they should keep a random slope variance of any kind. That is not technically correct, because variances don't have a symmetric sampling distribution the way that fixed effects do. They're bounded at 0. And the closer the variance gets to 0, the more that boundary is going to be a problem. So the more correct way to test whether you need a random slope variance of any kind is to do a likelihood ratio test. In practice, these things tend to agree, though, at least when you have a decent sized sample. So we would come to the same conclusion that we came to yesterday. The likelihood ratio test indicates that we don't need this quadratic slope variance along with these covariances with the other terms as well. So we could probably be okay leaving it out. Yes?
Please repeat, what is the correct one?
Likelihood ratio test. Difference in -2 log likelihood for a model that has it versus doesn't have it. Mm-hmm. Yes?
Is there a way to do directly in Mplus, or?
Nope. Yep. So this is, it's like, nope, you're good luck. So this is where bringing it in and out of R would probably help you, because then you could extract those objects and do an ANOVA or a RANOVA, whatever, do the math yourself. There are, it will make pictures for you if you ask for it. And there's also a diagrammer that will be made for SEM versions of this model, but not for MLM. I haven't played around with the graphics as much, but I know that you can ask for a bunch of different things. Unfortunately, once you ask for it, a window pops up, and to edit the graph, you have to point and click your way through all the settings, which is very annoying, especially if you have to do it for multiple times. So I don't do much plotting in Mplus. The only time that I do plotting in Mplus is when I'm running an IRT model and I want it to give me like a test information function or something like that that would be difficult to compute myself. All right. Any other questions about this version of the model? Do you want to see what it would look like as a single level SEM? Okay. So this is functionally, the code that I'm working with right here is the univariate version of a multi-level model, because I'm only predicting one outcome. But to extend it to multiple outcomes, you just list them, keep listing them. So those I'll have examples of that later this afternoon. But we can look at the SEM version, which is this one right here. So it's the other input file in that same directory. Example 1, model 3, SEM, attitudes, predict, slopes, etc. All right, does everybody have this one? Okay, so the first thing that I have to do is restructure the data. And this is something that you may want to do in your own package and then save that version of the data set. But I have some code in here for how one could do it within the program here. So Mplus has routines that are long to wide and wide to long to go back and forth. And I'm starting with the long version of the data, and I want it to become the wide version. So you have to tell it what the original variables were called. So I want to use risky and convert it back into separate columns, as well as time. Then what do you want them to become? So I'm naming this risky 12 through 18. And note the use of the dash as an abbreviation. It understands that I mean 12, 13, 14, 15, all with a common stem. You want to get in the habit for series of this to use the last digits as the thing that changes, not the first. That way you can use these shortcuts in terms of the code. Likewise, I'm turning age 12 to 18 out of time. So these are the exact occasions that a girl was measured on centered at 18. So these are not constants in this data set. I have to tell it what the identifier is that links the cases together for the same person, and that's person ID. And then what is the index for time? I'm using round age so that then I have these numbers that go with it. So the result of this is creating then a wide data set.
I'm shocked. Sorry, I didn't know you can do it.
You didn't? Well, so here's the thing. There's also a command in here that I'm not showing right now that's define, where you can make new variables, like if you want to do your centering or, you know, recode or whatever. But there's a weird order of operations that happens. And I've gotten into situations where, like, I want it to make this new variable and then reshape it, and it won't do it in that order. And so then it throws an error. So this is one of the few times where I got it to work without crying. If I get too frustrated, I just do it in another package, and then I feed in the data. Because there's no way easily to check that it worked. Like, you can't click on something and have a data set pop up like you can in every other package on the planet. Like, it's not represented in the system. So the only way that you would know that your code worked is if the analysis popped out without errors and it seemed reasonable. Yes?
What is the line? They're risky, and then we have this line?
Yes, that is a divider for sets of variables. And so you would put one of these between each variable that you want to unstack, convert from long to wide. That's my word for it. And so then wide to long would do the opposite, and it has a similar list of commands for how you would go back and forth as needed. Okay. Then from there, names is the names of the original data file that you're starting with, and so this is the same as what we had before. Then use variables has the names of the variables to be analyzed. So in the wide file, I'm using one column for attitude centered at 4. I'm using 7 columns for risky behavior from ages 12 to 18, and another 7 columns for age, because each person is measured at a slightly different age, even at the same occasion. Identifying my missing data code, and then this is the thing that I can't find in R, t-scores. I looked for it and I couldn't find it, and I asked everybody that I knew that I thought should know, and they didn't know about it, so I have to conclude it doesn't exist. Internet, prove me wrong. People do write me sometimes. Like, you mentioned this in your lecture, but actually it will work this way or whatever. Thank you for telling me. So internet, prove me wrong. That's what the internet is for, arguing with people. Usually anonymously. So what this is going to allow us to do is to, rather than fixing the factor loadings to constants that represent how much time has passed, they're variables. So the first factor loading is going to be the number in the column that's labeled age 12, and it goes through all the way up until 18. So this is how unbalanced time can be addressed within growth models in an SEM framework where it's single level analysis here. Okay, does that make sense, what's happening? Do you want to see the picture again? Would that help, maybe? Okay, let me get the picture out. This one. So these factor loadings in this example are fixed to constants because this would assume that everybody is measured at the exact same times. It's balanced data where everybody shares the same possibilities. But in this particular data set, the age 12 occasion, it's not like the girls showed up on their birthday, right? They came in sometime or when they were 12. And of course, this is fake data, but that's really how it works in the real world. Nobody wants to go to do research on their birthday. So rather than saying this loading is 0 and this one is 1, I'm saying the number that should go here comes from that column that's associated with that participant. It's called a definition variable more generally, but it's a way that you can have each of these boxes represent a slightly different occasion across subjects. Okay, does that make it better? Maybe? Okay. So that's what's happening by defining those columns as my factor loadings to be. And in this case, I have type equals random because I have random slopes. I don't have two level though, because this is a single level analysis, even though it is still technically a multi-level model. The way that I'm estimating it is as a single level model, where I'm using latent variables as my random effects. So the code is relatively brief, and Mplus has built-in conventions for defining growth models that have fewer words than this. And again, I'm doing more typing at the benefit of transparency. So I have to first shut off all of the observed variables' intercepts so that the information about their mean goes up to the latent variables. Typically in a measurement model, you would estimate each item's intercepts or thresholds and just leave them alone. We have to shut them all off by saying at 0 in order for this to work. I'm also taking all of the variables' residual variances, again that would typically be separate if this were a measurement model, and I am holding them to one number. So this label that I have in parentheses here is not just a label, it is also a constraint. If you type one number in here or one label, then it holds all of these parameters that occur before the semicolon to the same value. And you can type anything you want in here. Anything. As long as it's 8 characters or fewer. If you're going to have more than one set of these, though, you have to be careful not to reuse the same words, because then you're making the same constraint across lines. Not anything. Resvar, that's what I want. And I tend to name these in ways that I understand. So I am setting the residual variance across time to be the same. Then this line right here does the work of setting up 3 separate latent variables. And this is a shortcut syntax that you can use when we have exact age like this. We have intercept, linear, and quadratic. The bar then is defining how they're going to be measured by observed variables. So these are my outcomes. At is the keyword that allows t-scores to be invoked. And so then these are the factor loadings. And it understands implicitly that the first word you type here is going to be at 1 for the intercept. The next one is meant to be linear, and the next one is meant to be quadratic. You have to define the loadings yourself if you want to deviate from that structure. And I have examples later today of how that would look as well. And as well as, I think, in here. I have a couple slides on that. Yeah. So the long way to do this would look like this. So these 3 lines is what just happened. So by, then all of my outcomes at 1 in the first row, that's my intercept, according to the linear time vector in the second, and then quadratic time squared in the third. So these 3 lines in this example are being replicated by just this one line in this shortcut syntax. Then I refer to the fixed effects of my 3 new latent variables. I have the random effect variances for intercept and linear. Again, quadratic is shut off at 0 because I didn't want that. The covariance between the intercept and linear factors, and then the regression of attitudes predicting each of those. So this part is relatively similar to the level 2 model from before because it concerns only the latent variables. All right, questions on that? And if we wanted to turn this quadratic variance back on, it would be the same as before. Take off the 0. And add the covariances as well. So we can run it. And it warns me, all continuous latent variable covariances, including quad, have been fixed to 0 because the variance of quad is fixed to 0. Yes, that's what I wanted. But this highlights the difference in what a default is. In the MLM version of this model, the covariances have to be requested. Their default is to not include them. In the SEM version of the same model, the default is to include the covariances and you have to request them to be shut off. And this is why I don't like memorizing defaults. So I write the model that I want to have. So then the output is longer in this case because there's more parameters to discuss, even though there's still only 10 that's being estimated. So we have the 3 regressions, the covariance, and then it reports all of the intercepts that were fixed to 0, which is necessary to identify the model. It reports all separate residual variances per occasion, which are fixed to the same number per my instructions. And then the quad variance is fixed there too. All right, and I believe this is where they live, by the way. This is their home address that shows up in every output file. Stoner Avenue. I don't know because I think they're retired, and it's been Stoner Avenue because this company is not a university venture. It's their own thing. And I'm pretty sure the two of them sleep on a bed of money every night at this point because Mplus is very popular and very expensive. If you are a faculty member and you want a full licensed copy, that's about $1,000. And you have to pay $175 every year to keep it current with the updates. Yes?
Maybe it's easy to where did we tell Mplus that this is a SEM? Analysis? Nowhere.
No, nothing explicit, no.
That's like the default to just run a structural equation model if we say nothing else.
If you define latent variables, it is, yes.
Okay.
So this part defines the latent variables, and then we refer to their means, variances, and covariances and predictions. If I didn't have this, then I could do an analysis with just observed variables, which would be a path analysis or a regression, however you want to think about it.
Many times in the past when I asked in the Mplus forum, then he answered, just do a complex model. And I never,
Complex, type equals complex?
Type equals complex?
Yes.
So,
Yeah, I'm going to disagree with him on that. So what he's referring to is invoking cluster robust standard errors to your analysis, type equals complex. And that solves the standard error problem, but it does not solve the pushing together of between relations and within relations. So you will get a correct standard error for an incorrect coefficient. And to me, that's not better. So that's on top for today.
but that will be one level. The complex.
Yes, then it would be one level. That's the, I don't care about my groups, just make it go away. And you just type that in there and then it's poof, and it works, but it doesn't. It also, if you have sampling weights, that would also be a type equals complex. You can tell it to use strata and there's other words, I don't remember them, but I know that in certain disciplines, sampling weights are very important. And so there's layers of sampling weights that you can apply within this. That's also complex. The Mplus website, by the way, is a tremendous source of information. You can see all my bookmarks here. I've got it right here. It's statmodel.com. And let me make this bigger. They have their user's guide online, and it's like a 900-page book. And for every type of model that you can fit with Mplus, you can get examples of various kinds. So like here's the regression chapter that has input and output examples to do various things along with the data. And then the last two columns, by the way, are Monte Carlo simulations for power analysis. So it makes up data in which the relationships are known and then estimates, makes up like 1,000 data sets, for instance, estimates the model 1,000 times and compiles the results. And the proportion of replications in which you get a significant result is your empirical power rate. So it has basically ways to do power analyses for every single model that they have, that they've illustrated in these things. So then there's also a bunch of technical appendices, web notes, papers, there's references for things, there's special topics, and then what you were referring to, I'm assuming, is the discussion board where you can post questions and get answers. So it's there's a lot of resources here for how to do various types of things. But if you were to actually look at the outputs, for instance, title, this is an example of a path analysis with continuous dependent variables. That's it. There's your code. Names are model. And then we get the output. You get fit on this one since it's summarized by a covariance matrix. And then you get your input. So all of these examples show you how to type it. They do not tell you what any of the numbers mean. And that's why I have a job. If they ever actually interpreted their stuff, then I would be in trouble. But I think I'll be safe for most of it. They have a bunch of workshop videos as well, and some of that is publicly accessible, the ones that they aren't charging money for currently, I think. So a lot of resources on this website. All right. Yeah. Do you want to walk through the same model in lavaan? Or do we feel comfortable with lavaan? Because we didn't do that yesterday either. What do you think? Maybe quickly? A little bit? Okay. So I have the end of, example 1A, where we were yesterday, has lavaan code that I can walk through. And then it's in the R file as well if you want to run it. So I'm working, this data set started as wide. I reshaped it into long to do all the multi-level models yesterday, so then I'm going back to the wide version, and all I had to do was make a centered version of attitudes in that new data set, and otherwise I could use it. So then the definition of the SEM latent variables is right here. And note that there is no unbalanced time option. So I am pretending that everyone was measured at the exact same occasions because I have no alternative. So that's one of the things that Mplus has that lavaan does not. So I have a 1 as my factor loadings for the first row here, so I'm defining my intercept. So the name of the latent variable goes here, equal, and then I call it squiggle, but I think it's tilde is the proper term. Equal squiggle means by as factor loadings. And we put pluses in between even though they're not really added together. So it's more of a combination as opposed to an actual addition. Same thing with the new variable linear. So I have it centered so that 18 is my time 0, and that's why these numbers are negative, because these are going backwards in time relative to the definition of 0 at the end. And then quadratic are the same numbers squared. So then they turn positive. I'm listing out all of the fixed effects, which are considered the intercepts of the 3 latent variables. Then 2 squiggles refers to the variable's variance, and here I have the 0 with a star to fix it to 0, so that I'm not estimating the quadratic slope variance. And then I have the covariance between the intercept and the linear term. And I have no idea what the defaults are for this, to be honest. I'm just writing everything out. This is fixing all of the observed variable intercepts to 0, so that the information about their mean differences goes up into the latent variables where I want them. And then the constraint to hold each of the level 1 residual variances equal across time is applied by using the same label for all 7 of these, which Word is very unhappy about. And then last but not least, we get the regression of attitudes centered at 4, predicting each of the 3 latent variables here. Not really added together, but just combined. So it's a similar structure to Mplus. So then this entire object, which is just a text string, so note the beginning quote and the end quote. So everything is green because it's a string, but these are still comments that it will ignore, starting with either, if you're old like me, I call this the pound sign, but to you it's probably a hashtag. If you have a menu on a phone, press the pound key to do this, right? That's what they say. So then I feed that syntax object into the model argument of lavaan. I'm using the wide data set. I am asking for maximum likelihood estimation, and this, I think, invokes a bunch of defaults that are similar to what Mplus has. They have a couple different options for what this would be, and I think this is designed to help users transition from those other packages into lavaan. Then for the summary of the results, I'm asking for measures of fit. I'm asking for R-square statistics for the proportion of variance explained, and I'm also asking for the standardized solution. So questions on the code for this? Okay. So in lavaan, one of the first things that's different is, look, we get all of our fit statistics back that you would expect in a typical SEM. But in Mplus, I don't. The reason for that is because in Mplus, I am using unbalanced time, where I'm keeping track of exactly how old each girl was at each occasion, such that the entire data set cannot be summarized by a single covariance matrix. If I can't summarize it with an H1 model, essentially of what the right answer for the covariance is, then I can't do absolute model fit tests against it. Whereas in lavaan, I am pretending that I have balanced time because that's my only choice. And so now I have the right answer to come back to in terms of what the log likelihood would be if I estimated all the means separate, all the variances separate, all the covariances separate, and I can see how much worse my model is relative to that correct answer. So the model test, what we typicchi call the chi-square test for fit, this is a likelihood ratio test comparing the difference of the H1 perfect saturated model relative to my HO model that has fewer parameters. So I have 32 degrees of freedom in terms of things I could have estimated but didn't. And the p-value for this is non-significant, which is good or bad in this context? Good. That means that there is no significant difference between my model and the right answer. And that's because I made up the data. I win. If I had bad fit, then that would mean that I screwed something up. This one is provided but is basically useless. This is a comparison via a likelihood ratio test of the perfect model and a null model, which I'm not sure what it does in this context, but if it's the standard one, then it estimates all the means and variances, but then it shuts all the covariances off. So the only way that this test would be useful is to tell you whether you have any covariance worth modeling, which if you didn't, you probably wouldn't be doing this. So then we get our fit statistics relative to the null model. We get, here's our log likelihoods, AICs and BICs, RMSEA looks good, root mean square residual looks good, and so forth. And then in terms of the output, we have the same 4 columns that Mplus has, but it attaches the standardized solution to the end, whereas in Mplus, that's a separate section of the output. So then it repeats my factor loadings, which are all fixed, that define each of the 3 factors. And then here are the regressions. Thank you for labeling this. I appreciate that. Thank you for labeling this. And so then we have the intercepts. Again, these are the fixed effects, not really intercepts. Choose. And then the variances. And so in Mplus, it differentiates intercepts and means from predicted versus unpredicted, and residual variances versus variances. lavaan doesn't do that. It just dumps them all in one pile, which I actually prefer. And so then here are the results. They are close to what we got out of Mplus, but not exactly the same, because again, this model is assuming perfectly balanced time, whereas in reality it is not. And then here's the explained variance in each of these things. And the quadratic is perfectly explained because it didn't have any variance. So, ta-da! And what your activity was is to repeat this sequence of models for time-varying monitoring as an outcome instead, in preparation for actually treating it as an outcome today. All right, questions on any of that? Yes?
Why would we use lavaan if we can do it so nicely with Alma?
In this case, There is no reason. So I was, in my head last night, I thought of a couple more answers to that same question, like why would we do it this way? In this framework, you can have more than one outcome, and you can have your latent variables for intercepts and slopes be predictors of other things. You cannot do that in Elmer. In Elmer, there's only one outcome that is allowed. You can stack your data of multiple outcomes into one column to cheat your way through that, but then any relationship across your outcomes can only be modeled as covariances in the G matrix at level 2 or the R matrix at level 1. So there's more flexibility in what else you could put in here in this approach, but as I have it now, there is no difference. All right, other questions? Then let's see, it's 10:10. Would now be a good time to take our first break of the day? I think yes. Okay, how about we take 20 minutes and get some coffee and fresh air? 2 thumbs up for that. All right, see you in a bit.